Mm. Welcome to Saudi Critical Care Pharmacy Research. I'm Nadiyah and this is session 3. In this video, we will take a look at what is the difference between failing to reject the null hypothesis versus accepting the null hypothesis. How can we generate graphs in SPSS? What is multivariate analysis? And we will see the linear regression and how can we make interpretation, demi-variable, and multicollinearity. What is the multicollinearity? So here, when we start a research, we do hypothesis about characteristic of population we are interested in. Okay, so the hypothesis consider two different prepositions, the null and alternative. And here, the alternative hypothesis is an assumption that tests seek to support, whereas the null hypothesis is presumed to be true until tests provide adequate evidence that shows the null hypothesis is not true. So here we want from the sample, we do the sample data so we can know something about population characteristic from the sample. And if the sample we had not provide evidence to reject the null hypothesis, that is not proof the null is truth. And the reason, because there is still a lot of data about population we don't have. So if the sample cannot prove the the rejection of the null hypothesis, I cannot accept the null hypothesis because maybe there is missing data I don't know. So it's wrong to accept because we don't have all missing data about population, which is mean without the missing data, we just not know if the null truth or not. So the null hypothesis should not be proven, it simply reject or fail to reject. Okay? Now let us see how the graphs that can be used in categorical data. We can use either the bar chart or pie chart, and for numerical we can use the dot plot, steam plot, histogram, and box plot. How can we generate the graph using the SPSS? We will see now. How can we generate graphs using SPSS? We have, let's say I want to do a bar chart of to describe the age groups among cancer patients. And I will do either bar chart or pie chart. So I will go to analyze, descriptive, statistics, and I will go to frequencies, and I will put age group here, deselect display frequency tables, and I will press OK. And here I have the chart, the x-axis for the variable, it's here for my age or my variable, and the y-axis it for the frequency. Can I do modify on it? Yes. I will just double click. I can change the background, and also I can press on the bar. I do some modification on it, and then I will apply, and then I will close. Another way to do that is just by doing graphs, because the dialogues. I can choose any one of them, the bar and pie for categorical, and the dot plot, steam plot, histogram for numerical, and then I will define my variable and I can do the modification on it. Okay, so let's see now the multivariate analysis. When I say bivariate, I meant two variables, and when I say multivariate, that's meaning many variables. For example, I want to assess health score and eating vegetables, that is by and 2. But if I want to assess my output, which is health score, using multiple predictors such as high blood pressure and cholesterol and weight, that will be multivariate analysis. And in the multivariate analysis, when the output is numerical, my output or my response variable numerical, and the input numerical, I will use the linear regression. When my output is numerical and my input numerical and categorical, I will use ANCOVA. When the output categorical and my input is numerical and categorical, I will use the logistic regression. Okay, so let's see the example. I want to predicate the health score, which is numerical, using high blood pressure. The blood pressure, here I meant the blood pressure as a numerical, and cholesterol level, it's also numerical, and weight. So the output and the outcome numerical, so I will use the linear regression. Predicate the profit of hospital using number of beds and region of country. Profit, it will be a numerical, and the input here, it's a numerical categorical, it will be ANCOVA. Predicate whether or not a person will uh, comply with the direction on prescription using age, gender, and other medications. So here we have uh, whether the person comply to the direction, yes or no. So my output here is categorical, and the input here age, gender, and other medication, numerical, categorical, that will be logistic regression. Okay, so we will start with the linear regression. As we said, we have dependent variable and independent variable. The independent variable can be one or more explanatory, but both of them should be numerical data. Okay, and because we cannot add the categorical to the linear, there is something called demi-variables, which is mean I will take the categorical and I will make the coding for categorical. How can I make the coding so I can add it as a predictor in the linear? For example, if I have the gender, I will not make the coding like male is 1 and female is 2. I have to divide the gender into two variables, and then I will code female 0 and 1. Female, yes, it will be 1, and no, it will be 0. So I will define each variable alone. And I don't have to put all of the categories. I will add only the important one. Yani, let's say for example, I'm interested only in female, I can add only the female. I'm interested only in smoker, I can add only smoker, yes or no. I don't have to add non-smoker, yes or no. So when I have like a specific category that yes or no, I can predict how much can affect my response or my outcome. Here we have the multicollinearity. Sorry, it's a collinearity. When we have two variables, they have same measurement or they have similar things to measure. For example, when I have weight and body mass index, each one will cancel each other, and it's not supposed to be added in the model because it will generally destroy the model. So I have to be careful. If I have something or two variables, they are measuring same thing, they are not supposed to be add both into model. Okay. So moving now to the SPSS to see how can we do the linear regression and how can we make the interpretation. And we know we will do the linear regression. First of all, we know we will add numerical data and demi-variable. And if you notice here, I change the female, the gender, it was gender, so I changed the variable name to female, and I added like a yes if it's male, yes if it's female, no if it's male, and it will be no. And all of the categorical be coded like a 1 and 0. So now it's semi-variable, so I can make the prediction in the linear regression. And then I will check the assumption for the linear regression. For linear regression, my response or my outcome should be normally distributed, so I will check. In this case, let's say I'm looking about the physical function. What's the predictor for the physical function? So mainly here, the physical function is my response or my outcome. So I will check by using the histogram, is the physical function normally distributed, yes or no? And when it's normally distributed, I will move to see, is there any linear relationship between the predictor and my response? Supposed to be linear relationship. It's one of the assumptions. So I will go to simple scatter. I will add here, for example, pain as a predictor, and here my response, the physical function. Okay, and I will press OK. This is yani poor relationship, it's not supposed to be like this. If it's appearing like this, it means I cannot apply the linear regression because there is a violation of the assumptions. The predictors and my response outcome supposed to be appearing like a positive linear relationship or negative. If it's appearing uh, linear, I can move and I can use the linear regression. After checking the assumption, I will do the linear regression test, linear regression model, sorry. So by going to analyze, regression, and then to linear, and here I will put my dependent variable, which is the physical function. Here I will add the demi variable and the numerical data. After that, I will press on OK. Here we have. We will explain one by one what is the model summary. We will see the R square, and I will take the value of R square and I will multiply in 100, and it will give me an indication about the variation in my response. Let's see what that means. In the model summary, I will take the R square and I will multiply in 100 and I will get percent. In this case, it will become 27%. 27% of variation in my response, which is in this example, physical function, can be explained by the explanatory or the predictor, which is pain, age, and etc. That is the meaning of the model summary. I can report this one in the result part. How much percent of variation in my response can be explained by the predictors. We have the ANOVA. ANOVA, it's give me an indication if the model is useful or not. If it's significant, that is mean the model is useful. And then we will move to coefficient table. This table, I will see first the significance here, and I will see if it's categorical and if it's numerical, how can I make the interpretation. Coefficient table, how can I make the interpretation for this table. First of all, I will flag or highlighted the significance. Let's see first one. It's frequent hospital admission. And then how can I make the interpretation for frequent hospital admission? I will say the presence of frequent hospital admission tend to decrease, and the reason why I said decrease because here the slope was negative, tend to decrease the outcome, which is here the physical function, by 6.716, which is the value here. And I will write p value equal, and I will write the p value. Okay, this is if it's categorical. I will say the presence of these tend to decrease or increase. Decrease if the slope is negative, increase if the slope positive. My outcome by the value which is in the p, and I will write the significant level. Let's see the other one, the fever. We have here the fever. So I will say the presence of fever tend to, in this case, increase, because here I don't have negative slope, it's positive. Tend to increase, tend to increase the outcome, which is the physical function, by 5.978 and p-value equal 0.033. Okay, what if the predictor numerical? I will say as a predictor, as for example social function score increase by 1 unit, the predicated of outcome tend to increase by the value on the slope unit. So I will say, let's say for example we have the age was significant. I will say as the age increase by 1, the unit here it will be year. As the age increased by 1 year, the predicate of physical function tend to be increased by the number or the value in the slope, and the unit of the physical function it will be score. Okay, so this is how can we make the interpretation. And how can we report in the result section? First, we will say, for example, we have to refer to the table. So we will say, for example, table 3 shows the independent predictor of my outcome. And then I will say, according to multiple linear regression, our post model include, and then I will mention the predictors that added in the model. Then I will explain the variation by using r squared multiply in 100. So I will say, for example, 27 of variation in the outcome can be explained by these. I will mention the predictors. And then I will move to the p coefficient table, and I will see the significance, and I will see is it increase or decrease by checking the slope. I will start with the numerical data, and I will use as my predictor increase by 1 unit, the predicate of outcome tend to increase the slope unit. Okay, also I can combine, for example I will say my first predictor, let's say age and another numerical, if they are increased by 1, I will mention the unit. The predicate of outcome tend to increase by slope unit. And I can say it like this, gram, I will mention the value on the slope, p value, and let's say 43, the value on the slope, and the p value for the second predictor respectively, just to combine. And let's say we have gender, I will say being female tend to increase or decrease depend on the slope. The predicate of outcome tend to increase or decrease the outcome by the value of the slope and then the unit. That's all about how can we make the interpretation of linear regression. Thank you for time, and I hope this presentation was useful.